Okay. Please, everyone, open your Jupyter file. We're gonna continue with week 6 in pandas library. Okay. Okay. So in last lecture, we talked about Panda library, its feature, what we can do with Pandas library. We learned how to import it, and we said something really important about Pandas library, which is data frame. We said whatever data that we want to use in Pandas library and functions under Pandas library, we should have a data frame. What is that data frame? It is some data that have rows and columns, exactly like Excel. Therefore, whatever data we have, like arrays, that dictionary and list, we need first convert it to data frame and then use it. But when we use Excel, we don't need it because Excel is a data frame, okay? And then we talked about how to access to a specific part of that data that we have, like rows, columns, and how to concatenate or join and merge two lists, two data sets together. And we learn about drop, how to just do not like include some part of data and include the rest of data. We learned that kind of things, and we reached to level to import an Excel sheet, Excel file in our Python and start working on that one, okay? So today, last time, let me put this chat box down, then I can see all your my chat box does not show up. Okay, here. Do you all have the absentees file that last time I told you to download it? I'm gonna go in Google Drive. You all have it, okay? If you access to the Google Drive, I'm gonna now share this one with you too. Okay, copy link. Okay, I copied this link. I'm gonna put it in chat part, okay? Please go now and just download this part as an Excel, okay? Just download this part in your computer and let's put this data in our Python program. Okay, first we're gonna import our pandas library, okay? To make it short, we're gonna say pandas as PD, okay? Now we said how we can like import some data into it using that read function from pandas library. Therefore, how we write it, we say PD or pandas dot read. Okay, read what? Underline Excel. Okay, we're gonna read the Excel file. Excel open close parentheses. Okay, read is a function from pandas. Then we put first the mode. What is the mode? Do you remember? R. R means reading. Then this quotation mark, it can be single or double, doesn't matter. Okay. Here, inside the quotation mark, we put the name of the Excel file that we have. Sometimes your program cannot find. If it cannot find and give error that file does not exist, just go and copy paste the directory of your file, okay? From here, I just do it, absentees, okay? Copy full path. I copy paste that here, and that's it. So I'm gonna put, so this line is so long, and we need to keep using this data. Therefore, I create a variable and put it equal that variable. The variable can be anything. I call it 5, okay? I just call it 5. 5 equal this. To see, last time we learned when we want to import some quick data out of Excel sheets and see what kind of data we have, we use that info function, okay? Let's use that one. We're gonna say file dot info, okay? Info, open, close parentheses. And inside the parentheses, we have a keyword that all the time is like true. Null underline counts equal true, okay? Just write this one. And press Shift Enter or run. See, info is so useful. All the time, probably when you want to do this data analysis, you need this info function, okay? Info function quickly gives the attributes that we have, okay? What kind of attribute? This is attribute or variable that we have as a column in our Excel sheets, okay? You can also go and see that Excel sheet. It tells us how many values we have for each one of these attributes. We have 740. And non-null. What is non-null mean? Okay, non-null mean we don't have any empty place. They are all full with data. When it has some empty space and cell, it say no. We have some null like in ID part or in months of absences, okay? And after that, it gives the integer, the type of data that we have. So regarding this file that I have, I'm gonna give some information. This is a survey that done from employees who were absent in their work, okay? And they got some data. They wanted to understand which month we have more absences, which day of week we have more absences, which season, and how much is the transportation expenses of people who absent in work, and distance from home to work, the time that they work, and age, their education, if they're a drinker or a smoker, their body mass, and that kind of data. They wanted to see this data related to absentees or not. They can be a reason of absentees or not, okay? So we learn how to access to rows and columns. Do you remember that part? Okay, let's just quickly go through that one. So I'm gonna say file. If I want to like access to a, some row, I want to just show up some rows, we're gonna use this one. So, okay, this one shows our rows, okay? It say row from 0 to 1. Actually, let me put from 0 to 3. See, it printed out, is showed the 3 first rows, okay, that we have in our data. So if I want to put like I want to just show the season column, okay, let's put season here. Seasons, write exactly as same as it is here, okay? Season, Shift Enter. It just print out the column of season, see, from the 0 to the last one. If I want to put like 2 columns, I want it to show me 2 columns. I gotta put comma and then what? I gotta say H, show me H2. When we add more column, then we add also braces. We make a double braces, okay? Don't forget this one. Just make a double braces. And now Shift Enter. Okay, see? It just printed out seasons column and age column. So we learned this kind of things. Last time we learned about head, that head printed out the first 5 row, tail is the last 5 row, and we learned a little about count, mean. So let's play more like a statistic, okay? If I want to mean, okay, which mean is average of data that I have, I'm gonna say whatever file that I have, okay, that's file dot mean, okay? Mean is a function, therefore close open close parenthesis, then shift enter. Shift enter here returns the mean, the average of season and age column. See how nice it returned that one. So if we want to have the mean or average of the whole columns and data that we have, we just put hold the file dot mean, open close parenthesis. If I go fast, please tell me in comment, and I can go a little slowly. Okay, if I delete this part, it just returns mean of whole the data. See? So ID, it doesn't make sense actually ID have any mean. It's just ID, like name something, okay? What we can do here actually to write out of this mean. So it gave mean of the other, like body mass index something. That makes sense, okay? But for ID, it doesn't make sense. If you want to take out the ID, we were using that function that we learned last time, which was drop. Do you remember? So we could say just file dot drop. Drop, open close parenthesis. Drop was a function, therefore open close parenthesis. Okay. Drop columns, whatever columns we want. Okay, columns equal ID, ID. And now let's. Okay, see, I dropped. Here I came and dropped the columns ID. Now we do not have ID columns here, the mean of ID, because it doesn't make sense. See how I drop, how I take out that one and just told my program to calculate the mean of the rest, okay? We have other functions like a standard deviation and median and that kind of things, okay? So let's do like median. If I wanted to calculate the median, I just put this median function, okay, next to my file or a part of my file that I want to calculate it. Then shift enter. See, now I have the median of that part that I need. Okay. A standard deviation is same thing. STD. Okay, a standard deviation. Shift enter, it's gonna return a standard deviation of each data, each columns, okay, that we have. We also have that minimum maximum. Minimum maximum actually return the minimum and maximum value inside that columns, okay? We have a nice function. It called it describe. When we want to give like just want to have a like a general a static calculation and result from our data, we just use describe, okay? I say describe, just put describe function, that's it. I just wrote describe function here, see? That's it, okay? And then we can shift enter. Describe function is so cool. Look what it did. Actually, it returned, first it gave count. What is count? Count is the number of data that we have in each column, okay? 740 that we have in each column. So cool. See here? To the end, okay? and it gave mean, the average value in each column that we have. The next one is a standard deviation. The other one, minimum value that we have in each column, okay? And we have maximum here, then we have this percentage. This is so cool, this data to show in box plot. In data analysis, mostly we use a plot. We call it box plot. If you remember that one, there is a box plot that showed the 20% and the 75%, the 50%, and all the time, like mean is the line or the point at the middle of that box, okay? We're gonna learn that graphs next week in data visualization, okay? So when we have this kind of data, when we use other apps like pie chart, it actually printed out separately, then we can copy paste it or save it, but here it just bring it like this. We can do something so cool. Do you remember that we learned to create a file and put some data inside the file? Here we can do same thing, okay? We can put this data inside something, inside a text file, inside something, okay? And save it like that. Okay, here this line is the line that we're gonna use it. Because this line is long, I'm gonna create a variable and put this data equal to that variable. That variable can be anything, okay? You can call it anything. I just call it a static, okay? Let me call it a static. And I want to put this static in an Excel file, okay? How we do that? I say a static dot to underline Excel. It's gonna go to the Excel. And here we put the name of that Excel file. If it doesn't exist, it create for us. If it exists, it added to that one, okay? So let's call it something like results, file, whatever you want, okay? Something that you don't have in your computer. Let's just make it a like new one, okay? Let's do something like this and see what will happen. Shift enter to run, okay? Shift enter to run. Now, how we're gonna check? So we can go here and just search for this result. Let's see if we have some kind of file or not. Result. It was result. I run it. Shift. Okay. Let's search for it. Okay, result, I have it here. Okay, let's open this one. See how cool. It just printed out all the data that I created inside this Excel sheet. See, now I have all that data here. I can use it like this, okay? And put it everywhere, this data. So let's close it. This was a nice part of data analysis. Okay, now we're gonna learn a level more regarding data analysis. We're gonna create a correlation matrix chart, okay? Let's see what is a correlation matrix chart. Correlation matrix is actually a table that shows the correlation coefficient between each attributes that we have inside our data, okay? It's so easy. It's just a function which calls core. That's it. It's gonna create whole the correlation matrix chart for you without doing anything, okay? Let's use that one. I'm gonna put the name of my file, whatever I call it, and then use this correlation function, okay? Let's shift enter to run it. Let's see how nicely it is. It did all. My room is so hot because I have to close windows. There is too much noise coming from the street inside my room. Okay, what this correlation coefficient does. When we have correlation coefficient, I want to make this one bigger for you. And you can see whole like at the end and the beginning, okay? Correlation coefficient change between -1 to 1, okay? Anytime that we have this chart, it's from -1 to 1, and it gives a perfect data to us, okay? Now let's see what we can understand from this chart, from this data that we have. If you look at this data diagonally, okay, just look at this data diagonally. See how my arrow shows to you. Here is 1, here is 1, here is 1, 1, 1. Through the end is 1 here. When we look at data diagonally, it's 1 only in that part. Why? Because here is ID. It keep comparing attributes with each other. ID with ID, months of absence with months of absence. And what is the correlation of one attribute by itself? It's 1, it's 100%, okay, affecting itself. Correlation is show that how much an attribute can affect other attributes, okay? That's the point of correlation. So if the correlation is positive and close to 1, it shows that these attributes affect this one too much. They have a positive and a strongly correlation to each other, okay? If it is minus, close to -1, that it is a negative correlation. That means when one increase, the other one like decrease, okay? They're vice versa. But positive correlation say when this one increase, the other one also increase, okay? So here, when we create this kind of graphs, the first thing that we are looking for highest correlation and lowest correlation or negative correlation. Lowest correlation actually is that one that it is close to 0. That means they don't have any correlation with each other, okay? So we look at for the highest correlation. See, this 0. 0.9, do you see it here? Okay, 0.9 actually is really high correlation. Let's see what it says. Weight to body mass index. Absolutely, they have a positive and high correlation with each other. So when weight increase, the body mass also increase. See how it works. If we find a like negative, a big negative, we have here minus 0.3, which is ID and body mass. Yeah, they don't have anything to do with each other. Here we have minus like 0.3. Okay, I cannot find the ID part. Do not look at the ID part because ID part is just ID. Absolutely, it doesn't have any correlation. Okay, so here I found out what. I found something here like minus. This one minus like minus 0.35, so which is height and distance from residence to work. Absolutely, like totally they don't relate it. Here just show that they have negative correlation. Okay, so this is what kind of data that we understand from this correlation matrix, which is really cool, and probably most of the time you're going to use it in data analysis. Okay, for this part I'm gonna add another Excel sheet, which is more useful and nicer to use with it. Inside Google Drive you have that one. Okay, I put it for you there. Okay, let's go here. I put it somewhere, that one. Airfoil noise. Okay, let me share this one with you. If you cannot enter like Google Drive, I don't know if you have access, you don't have access, so I can also give the website to you to go and download it from there. But it should be absolutely like here, okay? Now you can download this Excel sheet just from this drive, okay? Go and download that one. We're gonna put this Excel file inside and also check the correlation among that data. This correlation matrix actually works really well in lab data. So you want to figure out the correlation among all your attributes and measurements. So it works really well over there. Okay, I'm gonna put the name of like my file equal pd dot what? Create Excel, okay? Create Excel. Do you remember? I want to add the other Excel file into it. R, the mode is reading, okay? So inside the R, I'm gonna put this, what is the name of this one? Let me see. Airfoil underline self. Airfoil. Okay, that's this one. I'm gonna copy full path, okay, and just put it here. Nice. Let me add. Okay. Let's look at read. I just want to print it out. Okay, let me print my file. I want to look at the data that we have. Okay, so we have 6 attributes. Let me also print out info. Okay, I'm gonna say my file dot info, and it was null underline counts equal true. Counts equal true. Okay. Let me just comment this part out. I want to give that take out that info. Okay. It say we have total. We have 6 column or 6 attribute, which is frequency, angle, call length, velocity. So big as well. Okay, let me go to data where I found this one. Okay, I went to this website. I went to this website to find this one. Okay, Airfoil self-noise from NASA. Okay, this website is a good website that give us just free and public and that Excel data. Then we can go and practice on them. Okay. So airfoil self-noise actually is about noise that generated by an aircraft. Components of the total airframe noise is the airfoil self-noise. So here they try to figure out the level of sound that produced by that engine, okay, the aircraft engine. They wanted to figure out how they can decrease that sounds, okay? They have 6 attributes, which is frequency in hertz, angle of attack in degree, chord length in meter, free stream velocity in meters per second, and suction side displacement thickness, okay? And also they have a scale of sound pressure level in decibel, okay? 6 is actually the sound level that they checked, okay? So One of the best things that we can do in this kind of data is correlation. We are looking to see what affect actually the sound level, okay? The first thing that comes to our mind as a data analysis is to check the relation among them.
Yes, is an enormous respect for the players who came before him. I think that's why he's reticent to discuss any kind of greatest discussions or anything like that, because he feels it would be disrespectful to the people who came before him, from Bill Russell to Jerry West, Dr. J, and even Marcus Johnson. He was a huge fan. So
I think the mic of someone is open and just sounds coming from here.
I think that he certainly envied the mountaintop that they were on.
Okay. So let's do correlation of this data, exactly like the previous one that we just did, okay? I'm gonna put, so I did what I call it my file, okay? See my file dot core and open close parentheses. So we have frequency, angle, and what is this? Co-length, velocity, and section thickness, and this one is sound level. Okay, the last one. It said they're all float. The first one, frequency, is integer type, and they are float, and they don't have null, meaning they are non-null. We do not have any missing value in these data. Okay, they're all filled out by data. So let's print out this part and see how nice we have a correlation. Okay, chart here. Diagonally, we see that once. All the time in correlation matrix, we should diagonally see once, okay? Because frequency correlation frequency with itself is 1. Let's looking for the highest correlation with this sound level. We was trying to check what caused the sound level increase and what decrease, okay? Let's check the highest correlation in this part. Actually, in this part, highest correlation is velocity, speed. It looks like when we increase the speed, it also increases the sound, which is logic. Yes, it makes sound. And negative correlation is about this section thickness minus, no, that's one, frequency. It is about frequency that they have a negative correlation. That means when we increase the frequency, that one a little increase the sound of that engine. See how nice we could figure out all this data out of this correlation matrix that we learned, okay? Data analysis all is about this. Now, for this weekend project that we have, I'm gonna show you some useful functions that you can work with that one, okay, for data analysis. Let's learn some more functions. One of the things in this kind of Excel sheets is data type. So we all the time do not have same data type, okay? Sometimes it is a string, sometimes it is float, sometimes it is integer, and some of this statics and mathematics function do not work on a string, okay? Sometimes we need to change the type of data that we have. There is a function that we can use for that situation. If you had, look, most of the time we have just numbers, like float and integer in our data. Even in survey, when we want to enter a number, how we say, like that season part on the previous Excel sheet that we had. So season, they just entered for season 1, 2, 3, 4. Okay, for months of the year, they just enter, like for January, they entered 1. Most of the time we do this. But if we had like a string, or we want to change our float to integer, we have this function, okay? we call the file, or here I had my file, okay? My file dot whatever, okay? Like if I want to just change the data type of like a specific column, because probably most of columns are not a string or not integer or not float. Probably just one of a column is a string, like name. Probably we can have a column, it is name, and it's just a string, okay? We can change that one part. Here I want to change the type of this frequency, okay? I just say, okay, frequency. Frequency equal file, my file, okay? The name of file that you have, dot the column that you want to change data type of it, okay? Frequency dot as type, okay? Now we want to change it. It was float. We want to make it integer. Let's see how this one works. And now just print my file, okay? Okay, it came and changed the frequency like this. You see? So here is, this is just a correlation, okay? Do not look at this one because this is correlation part. This was the main one. No. Let me print my file before this changes. See now if I can print that part or not. If you want to see. So I think it was 0.8 something. Now it made it 800. See, it just made it all integer. Actually, we shouldn't do this kind of changes because it messed up with all data, correct data that we have. But sometimes if for a specific things that you need, you do it, okay? Let me see if it's gonna work. Okay, yes, it changed it actually. It changed it in this part and this part. I think we need to delete this part or just comment out and then print it to have the like main data. These changes that we did, like this integer and any changes that we do, they're not permanently. They cannot touch your real Excel file. They just can change it in your program, okay? If you delete, if you close anything when you open, go and open the Excel sheet, there is no changes in that one, okay? It just changes here. So to learn this part, I'm gonna comment it out and just have my real data, okay? From here. Probably it was integer already. And okay, we said, okay, we have this one, and actually I showed how we can calculate the mean or a specific part of this data, okay? Here, if I want to calculate the mean of some columns, or I don't want to just add or calculate the mean of one column, so I take it out with drop, or I add it with using that braces, okay? For example, I want to, my file, okay, I want to calculate the mean or whatever, okay, of some columns. Like my first column can be like angle. I want to calculate mean of this angle and want something more like velocity, and probably something more like what? Frequency. For this part, when we added like more than one columns, do not forget to add braces, okay? Braces and dot, whatever that you want here. Like I want to calculate mean. then we added that mean function. Okay, here, see, it printed out. Here, it printed out angle. Okay, angle, velocity, and frequency, the mean, average of that one. So cool. So if we wanted to drop, we use that drop function. Okay, just we put dot drop, and inside that drop, we were using that column equal the name of the column and then dot mean. Okay, we just use that for two. Sometimes, so here we do not have any null value. Okay, they're all filled out with data. But sometimes our data has some empty cell, which can cause some errors when we do calculation, okay? When we want to fill out that cells with some numbers, with something, we can use fill NA. There is a function, call it fill NA. We can use that word to fill out a cell which has null. Okay, have we understand if our data has any null part or not with info? Do you remember that info was giving us that if it has like non-null? Info was giving this part to us, if it is null or non-null. Here we don't have any empty cell. It all filled out. But it had, if it said there is a null part and you wanted to go ahead and fill it out, what we do, we use a function which call it fill NA. Okay, like I use my file dot, and here I put exactly the column, the name of the column without any quotation mark. Okay, just like angle. If it is angle, just angle. Okay, probably I have a null part in angle. Okay, angle equal my file dot angle dot fill NA. Okay, fill NA. And inside this one, inside the fill NA, you put something that you want to fill it out. That null part, empty cell with that part, okay? If you want to, like I gave an example, if you want to fill it out with average of that columns, commonly they do this, okay? To match everything up. They just added the average to that empty cell to remove the errors, and also the data doesn't change at all. See how they fill it out. So if you add average to that empty cell, it removes your error if you have any, and your data would not change. Okay. To add that average, we learn how we calculate the average. My file dot what? Dot the column average we want to add to that empty cell of that column. Okay. Like it is angel dot mean average. Okay, that's it. This is the line that we use it for fill up all null cells or empty cells. Okay, we have some handy and nice function to having and picking up a specific part of our data and start working just with that specific part. It is so easy, easier than previous function that we learned. Actually, it's similar things. iLock is exactly work like indexing. Okay, iLock is actually do a slicing by index number. Okay, you just added index number to that. How we use that part? I say my file dot iLock and open close braces, and inside the braces we passes two values. Put a colon, comma, and then colon. Okay, the first column is for rows, and the second one is for column. Okay. So for arrow, I'm gonna say, okay, give me data from column, no, rows 3 to what? To like 10. Okay. And for columns, give me from 0 to 2. Let's run this one. See here. It came up and gave the part of data, which is row, is from 3 to 10, not including 10, okay? Goes to up to 9. And just included the 2 rows that we mentioned, the first 2 rows. What we said here, we said 0 to 2, column 0 and column 1, which is frequency and angle. Here just gave out that part of data. And you can just have this one, make this one equal some variable, like my data, something equal this variable, and keep using and do some specific calculation, and like I'm gonna do like what? Say my data dot describe. Here, see, it just gave the description and a static part of that 2 parts. See, it gave count, mean, a standard deviation, minimum, maximum, and percentage. So cool, so nice. Okay. I'm gonna just comment out this line because this line keep printing out this data here. So we learned this ILOC. This ILOC is so useful and easy. All the time you can keep using this ILOC. Okay. Also, we have something called sorting. Okay. Before sorting, we have something else. We also can add like columns at the end of our data, like here. Okay, here I can add some columns at the end of this data. Let's see, my file, open close braces, and quotation mark. Inside the quotation mark you can put any name. Okay, put it equal 1. What it say is say create this column, okay, A, and fill it out with number 1. Let's print out my file here. See, at the end of this column, okay, I added this A. At the end of this data set, I added this column A and fill it out with number 1. See? And also we have sorting. What sorting does? By sorting, we can say, okay, just print it out. The data that has this value, has this amount, is bigger than this one, something, something. Okay? We use that logical operations. I'm gonna say like my file, okay? My file, open close braces. Okay, my file, open close braces, and inside it also I'm gonna put my file like what, angle. Okay, I'm gonna put angle here, the column that I want to have it. Okay, angle equals 0. Here what I say returns a part of data where in my file column angle is all the time equal 0. I said logical operator. Okay, in logical operator we have equal, we compare. Okay, we want to check equal. Don't forget that equal. So my file angle equal 0. Let's run this one. Let me print, comment out this one, and let's run it, Shift Enter. Okay, see, it just printed out this part where angle is all 0, okay? It printed out a part of data where angle is always 0. See how we, can just print out a sort of data. And also that sorting part, even we can sort it with like, I don't know, velocity from like decreasing to increasing, something like that, okay? How we do that part, I say like my file dot sort underline, okay? Underline values, because we want to sort the values by what? By equal a column. By what? By a column. So here I want to sort all values by the column of velocity. Let's see what will happen here. Now you see here my velocity goes decreasing. Velocity goes decreasing, okay? And see here my actually indexing part change. See my indexing part here change. Here is 289. And here suddenly got 0, here is 970, and like 770. Here it changed the indexing part. This one is bigger than this one. So, but it sorted according to velocity, okay? We have something, the last one that I'm gonna show you quickly, is some calculation that we can do with the values inside the column, okay? So fast, we're gonna go and learn that one, and we are done with today. There is a function in pandas called lambda. Lambda, okay? Lambda make us to do some calculation, okay? We can say lambda x or whatever, okay? Colon x, whatever, you can put minus 2. Let me put minus 2. Okay, I said x minus 2. What is that? X actually is the value, okay? Here x considered as a value inside that column. I'm gonna put this one equal a variable, okay? When we create a variable, that make it short and easy to use, okay? Like calc equal. That's see. And here I come and say my file, which let's add this -2 to angle, okay? We want to see how this part change, okay? I'm gonna put angle here and say this part equal my file, open close braces, put a column inside the angle, okay? Angle column of my file, okay? Data set dot apply. So let's use that apply function, okay? Dot apply what? Apply this calculation to these columns of data set, okay? I'm gonna say calc, and let's shift enter to see what happened for angle. And let me print out also this one or my file. Okay, see, when I commented -1, actually it came and changed the number. See how the number changed. Here now we have -4. See, then I added this -2 to my angle. It changed your number according to what it is here. If I put like multiply 2, see what will happen. Okay, it multiplied by 2, see? Now it was 4, it multiplied by 2, it got -8. It was -4, by multiply 2 is 8. Here it was 11 something and got 23 now, okay? These were all functions for today that we learn, okay? For next week, like for this weekend project, I just ask you to go and practice pandas. Pandas is so important because the next week we go to visualization to create graphs and everything, okay? And we use, beside this visualization, we keep using these pandas and importing our data to a graph and print it out as a graph or some chart, okay, and plots. So this weekend, I put here, I want to copy this one just. I put this website for you, and you can find it in Google Drive in a slide, okay? Go and use this website. Even I put it here, okay? I put it here. You can go and use this website. Let me go through this website and show it to you how to use it. So here, so nice. Here we have view all data set. We have different data set, most of them in Excel part. Remember, download it as an Excel part. Otherwise, you need to change it to data frame when you use it in pandas, okay? Like here is regression, some cluster, regression, air quality. See, I take it that data from here. It's attributes information, data set information, data folder. They have a kind of data folder as a zip, then you can download it. If they have Excel part, or you can make it imported as Excel, okay, and keep using and practicing. Practicing that functions about pandas that you learn, okay, in that one. So do you have any question? If you have any question, you can ask me. Otherwise, I see you all Tuesday and have a great weekend.
You too. See you Tuesday.
Bye.
Happy practicing, everyone.
Bye.
Bye-bye. Thanks.
You're welcome.